A very good evening to everybody who has joined us. Welcome to the 6th session of the Professional Development Program organized by BMS School of Architecture in collaboration with the Indian Institute of Architects, Karnataka Chapter. Today's session, titled Robotics for Architecture and Construction, will be presented by architect Aldo Sollazzo. And I know that we're all looking forward to it, so I shall not take more of your time. And now, without further ado, I'd like to introduce Aldo. And Aldo Sollazzo is the founder and director of Numena and Reshape, which is an innovation platform. He is the director of Master in Robotics and Advanced Construction and the director of the Global Summer School at IAAC, which is the Institute for Advanced Architecture of Catalonia in Barcelona, Spain. And in 2019, he was conferred the Knight of the Order of the Star of Italy by the Italian President of the Republic for the promotion of national prestige. So, and if you go through the body of work that he has done, you will see that he is an active participant in various conferences, and he is extremely active both professionally and academically. And Aldo, we cannot thank you enough for joining us all today and giving us your time. And now, as we're all really looking forward to this session, I would like to hand over the platform to you. Thank you, Aldo.
Thanks, Shreya. Let me thank you and Professor Shashank for this invitation. I'm extremely grateful, and I really apologize to both and also the audience for shifting the original timing, but unfortunately I really couldn't fit in the original one. But for me, it was also very important to be part of this session together with you. So thanks, Professor Shashank, and thanks, Shreya, also Architect Shreya, for this invitation. And I would like to share now the screen and start to share with you this trajectory and experience that is connected to the world of advanced construction and robotics in the world of architecture. So, okay, so just let me start sharing the document. First of all, you already gave an introduction of who I am. I opened the company of Numena in 2011, and since almost 10 years, I'm also working with the Institute of Advanced Architecture of Catalonia. The institute is located in Barcelona. We have different facilities that are distributed along the city, but we mostly work around the topic of research, education, development of solution and agendas that can also go beyond the pure academic interest. And we organize, I mean, as you do in your university, in your school, a series of events like this one, exposition, publication, podiums, etc. But in Barcelona, IAC, the Institute for Advanced Architecture, is also very important for the presence of one of the first Fab Labs in the world, Fab Lab Barcelona, which became a crucial point to spread this philosophy of advanced manufacturing and digital fabrication. And this philosophy is the one that I guess you also know, is a philosophy that connects all the new tools and new instruments that are arising in the world of design and manufacturing towards a new industrial application that can establish on the other side a new agenda on how things can be made, how can we be more efficient, more resilient, more sustainable in the way that we think and make objects and projects. So in order to make, we use a lot of cutting edge machines that I'm also sure you have it in your facility, from big 3D printers to CNC milling machine, robotic arms. So these are the instruments that we use to manipulate matter. But on the other side, we also like to introduce codes and algorithms that allow us to program digitally spaces, and control variety and geometrical solution that at the end respond on the other side to a specific manufacturing process. Of course, all these criteria are always connected on how to even historically, if you look at the history of building information modeling, Barcelona is a starting point for all this way. You can recognize on the left side the drawing and the sketches and the 3D model of this installation by Frank Gehry, and is an installation that represents also the very first application of BIM, Building Information Modeling, that wasn't even called like that when Gehry was implementing it, but how to connect, again, morphology, complex morphologies to a new fabrication protocol that allow from the digital to shift back directly to the physical environment. And again, the digital and the physical are two main cornerstones of who we are in Barcelona, but also how we operate in this ecosystem. All the world of Fab Labs that we initiated from the Fab Lab Barcelona is now counting on thousands of laboratories that are distributed all over the world. And in fact, collaboration and ecosystems are the one that we are deploying and developing the most. From the local scale to Catalonia, to the national scale of Spain, and then the international scale of Europe, we collaborate, and the world, we collaborate with many companies, industries, research centers that are developing together with us and contributing together with us to the evolution of what is architecture, the big question, what is architecture, what an architect should be looking at in the future, and how can we introduce and bend all this technology towards more sustainable and resilient solutions. So in IAC, again, we work on the multiscalar, with a multiscalar approach. From the city scale to the material scale, we believe that everything can be programmed. In every object, we can include an embedded intelligence. But at the very end, we have a lot of tools, no? We have a lot of tools, we have a lot of instruments, but as Cedric Price says, technology is the answer. But what was the question? So why do we need all these instruments? No? In which direction shall we use them? And in IAC, for more than 20 years, we've been advocating the agenda of self-sufficiency. We've been speaking for 20 years about climate change. We've been speaking about energy, sustainability, but even more narrowing down the problem, we want to speak specifically about the problem of inadequate housing, the problem of greenhouse gases contaminating the air that we breathe, and then the lack, the presence of a standard solution that at the end are extremely inefficient were implemented. So we want to tackle the world of construction because we believe that thanks to the convergence of all these solutions, we can shift toward fast and cheap new forms of construction. We can introduce new sustainable approaches to our built environment, including custom solutions that can encode local intelligence. So at the end, we are also witnessing, all of us, all over the world, trends that are becoming extremely, evident in the society nowadays. The shift from the first industrialization to the movement towards the fourth industry, to the sensing and cognification of machinery, is evident that the path that we are establishing, the historical moment that we are living, is a moment that wants to rethink how processes are made, rethought also the existing process of production and consumption. And this is why also in our university, in the trajectory that we trace together, we are always talking about these two parallel way of looking at these protocols, from linear protocols of production and consumption to circular process, where in fact we can shift from one model, from PITO, product in, trash out, to DIDO, data in, data out. So we believe that we can, in fact, produce and promote circular ways of thinking material, consuming, producing materials. And this is also an important agenda of the Fab City protocol. That is an important movement that we also initiated and now is spread all over the world in Barcelona. So if you look at the world of not only the world of construction, but if you look at the existing trends that are connected to our built environments, is the first time in the history of our of humanity that the majority of people are living in cities. So cities are becoming the main habitat where to experiment and new criteria, new models, and also new habitats where it's possible to test and improve the way that we look at production, the way that we look at consumption. But nonetheless, I mean, if you look at the different sectors, the evolution of all the different sectors of our society, from manufacturing, agriculture, transportation, the one of construction is improving, is evolving in a very slow manner. In fact, our sector, the sector of construction, is less digital than fishing and hunting. It's the less digital sector in the world. And but on the other side, if you look again at those trends, what is happening is that the cost of innovation and the cost of implementing digital machinery is going also extremely down. And in fact, is also the first moment in the history that implementing system of automation as robotics becomes even cheaper than working with human labor in some cases, which doesn't mean that we are going all to shift to robotics, but you will see in a moment how we look into this and which are the opportunity under the drop of those costs. So what it means that this is the moment of innovation. This is a moment where innovation happens. Innovation can become mature enough to be digested by our society. And this is the moment where we can really not only start to think about new protocols, but we can really make it true. And in fact, it's time to rethink digital fabrication, and it's time to rethink the world of construction. This is what we this is the trajectory that we are going through in the Institute for Advanced Architecture of Catalonia. And we are doing it rethinking process of manufacturing from subtractive manufacturing to pick and place, then carving systems, 3D printing, spraying, and other protocol of additive manufacturing. We are constantly exploring what is next and how can we manipulate materials, including automated protocols of construction. What you see here, for instance, is a small pavilion that we deploy with our robot, a pavilion that was created using a pick and place system that allow us to control and gather material, and from this material start to automate all the process of manipulation over these individual sticks, creating a pavilion where every single item and every single element is different from the one before, but nonetheless, they all respond to a global intelligence. Okay? So this is one of the process for the construction of this system. And the interesting part is that it was the real beginning of this project, I mean, of this new agenda of construction. And I also invite you now with the next project to see what else we've been experimenting, always including robotics as at the end an initiator where all the creative part happens from the end effector on. So if you are a little bit familiar with 6-axis robots, you know that those robots are robots that have been existing in the industry of automation for a while. These are robots that have been implemented mostly by the car industry. But nonetheless, with these robots now, architects, designers, makers can also start to rethink the way that we manipulate, control material properties. And we've been working, for instance, with this project that is called Material, on 3D printing in the air without the need of any support. By doing what? By mixing a normal extruder. And this is also another project that I invite you to have a look at. But again, material for us are the cornerstone. Material for us are the key ingredients that allow us to introduce innovative process of manufacturing, and materials are the one that we are experimenting and researching a lot at IAC. From wood to adobe to biomaterials to bioplastics, concrete, aerogel, nanotechnologies, we are all the time investigating over the new capabilities of materials to establish more complex, responsive habitats that can also be controlled and manipulated by automated process of manufacturing. So in 2011, we started this research over clay, and we started to see, in fact, how this ancient material, noble material that is part of the first chapter of the history of construction of humanity, could be introduced in a new system of construction and automation. And what happened is that this project started to evolve through the years, through the students, and this is also something extremely important. I don't know, I see a message here, but yeah, see this message is not for me. And this material has been controlled and improved through the years, collaborating also with new architects, students, etc. And through this process, we didn't only improve the material quality, but we started to increase as well the composition of the material, facilitating the hardening process behind it, and improving not only the material, but also the instruments of manufacturing. So these are all the different iterations that we've been doing, and these are also the iterations that in parallel we've been creating. For us, an hands-on approach is what we always promote in our school, in our university, and it's a hands-on approach that is extremely transversal. It doesn't only rely on the design part, but it also relies on rethinking our instruments, redesigning our instruments, implementing, as I said before, protocols of design and manufacturing that allow us to fabricate and then in real time sense and perceive the manufacturing process, allowing our system to adapt and correct whatever they are building. So this is for us a new protocol of cognition, is a new protocol of increased intelligence, where the manufacturing process becomes a responsive protocols of construction that allow us to adapt material changes and design protocols also to a new complex environment. And in this field, machinery becomes crucial to deploy a new responsive system of design and production, and for us becomes also another ingredient for creativity. In fact, we like to rethink our tools, our machines, and these are some of the machines that we use, from six-axis robot that you already saw, to individual instrument drones or rovers or cable bots that we use to control and invent new one-to-one scale process of construction. So in this case, we created a huge 3D printer of 10 meters by 5 that is implemented using a machine that is already present in the industry. It's called CableBot, and this cable robot was converted from pick and place to a huge 3D printer. And the interesting part is that we started to use over and over this machine, and we started to encode into the protocol of design and manufacturing of this machine new system of construction. So in the case of Construmat, which is a very important fair of construction, we presented to the rest of the world in 2017 this new system where sensing devices as drones were cooperating inside the cable box with this machine that was 3D printing clay. And on the other side, these drones, our drones, were extracting information that could allow us to understand in real time what the machine was fabricating, and in real time send command feedbacks to the machine to correct and adapt to whatever was built. So this is at the end the manifesto of a new protocol of construction where fabrication becomes extremely intelligent, where fabrication becomes, as I said before, a responsive system of construction that really is capable of reading whatever is producing and adjust to all the protocols of production and fabrication. So whatever is behind it is connected to this new system, and that's young Aldo that is talking about this project. But aside from that, what I one second. Okay, so whatever you can see is a little bit how this project was carried on, and it's complex. Also, the ecosystem behind it is quite complex. If you want to build innovation, you need to collaborate. So the different technology that you see here are the result of a convergence of Tecnalia, IAC, and my company of Numena. They started to collaborate together in this very important fair of construction in order to deploy this new manifesto of fabrication. And these are some of the results. So in 5 days, we printed more than 7 kilometers of clay, creating this small pavilion that at the end is just a promise of whatever is possible. But this pavilion was then destroyed, and we used all the material. So this is also another interesting experience that is connected to the circularity of the manufacturing process. And with the same material, we started to create a new building in the open thesis fabrication together with Edouard Cabey and Alex Dubois. So let me now shift to another robot. This is one of the best projects ever in IAC. It's a project that is called the Mini Builder. And with this project, we wanted to rethink how a complex manufacturing process can be generated. So what you saw before is a big machine that we use to fabricate a big element. But we started to reconsider this paradigm, and we started to discuss what was possible to do if we were just discretizing the manufacturing process, creating a swarm intelligence that could allow us to fabricate big components by using small robots. So in 2013, we came up with this process that is called the Mini Builders, and with these robots we were experimenting how each one could respond to a specific task. So we had the first family of robots that were setting the foundation of this structure. A second family of robots, that is the one here on top, that were creating let's say, elevating this construction in space. And a third family of robots, this one working diagonally, that were increasing the stiffness and the structure and the rigidity of the wall structure. So this is one another very important line. And a third one that I want you to see is connected to all the ecosystems that are not purely built. So if we talk about technology, evidently we want to also talk about ecology in AIAC. And for us, living organisms and habitats, like the natural habitats, are fundamental. With the project of robotics in microfarming, we've been exploring how to integrate automated system of robotics in order to improve the efficiency of a farm and start to help farmers, thanks to this sensing technology, to understand also how to improve the yield and create healthier and much more plants from their crops. So at the end, with all the project of AIAC, we are also experimenting not only materials, not only new protocols of robotics that can manipulate our habitats, but also new composition, new elements that can become part of a more complex architecture that wants to respond, that wants to adapt, that wants to adjust to this complex environment where we live. So all the material intelligence that you saw before and all this possibility to include programming behaviors into materials is represented over here with a full range of material possibilities that we've been fabricating and deploying in AIAC. So here you can see at the end a series of some of the results of whatever we've been fabricating. So materials that can respond to the humidity, material that can inflate, material that can control the temperature of a given environment, but material that can regulate the ventilation, material that can absorb the humidity from the air, that can generate energy, that can be programmed through advanced polymers, that can be reconfigured according to shape memories alloys. But all these materials and all these new components of architecture that we are experimenting at the end are represented by one-to-one scale buildings that we are, an installation that we are constructing. From the very first digital fabricated house that was built in the world, that we constructed, that we built in 2009, 2008, in the solar decathlon, that's the Fab Lab house, to the artistic facade that were installed here in Barcelona and built with the 6-axis robot. But we don't only do, buildings, we also do interiors. This is the pixelated picture that you see is because the picture was very old. It was from 2007. And it was, as I said before, is a picture taken to the first digitally fabricated building in the world that was designed according to solar performance. So we optimized the shape, trying to improve, expose for as many hours as possible those panels to the sun. And then every single component was digitally fabricated by computational design. In 2018, we also presented to the rest of the world the first 3D printed bridge that was installed in a public space in Madrid. And this is also a bridge that we fabricated together with Acciona and Enrico Dini. It's a bridge that was fabricated in 3D printing. And it's a bridge that had to cope with a lot of complexity when you build innovation. Complexities that are also associated to legislation and the need of shaping, modifying whatever is already established. And the interesting part is that when you do innovation, you need to do it 360 degrees. So not only in terms of design, but also in terms of introducing this innovation into a society that might not be ready for it. And I'm sure that you know what I'm talking about. And then how can we start to increase the intelligence of our built environment, improving the thermal performance walls. And this is something that we experimented in 2012, or how you can start to cope with the topic of personalization using customization as a new instrument, no? As a new medium to maybe even artistically encode aesthetics, performance, history, etc., with this process. And the interesting part is that when you start to do something like this, you start also establishing bridges with craft, bridges with industries that are already operating in the environment. And for instance, in this case, we started a collaboration with a very important ceramic industry in Barcelona, showing them whatever was possible to do implementing 6-axis robot, and how we could use these robots to manipulate clay and doing it in an artistic way. So we encoded the Beethoven music into a series of algorithms, and we created a new material process where the robot was carving deeper those panels according to the highest note of this music. So here you can start to see the movement of the robot, and now this movement of the machine were carving those ceramic panels according to the notes of the music, and all this part was then converted into a facade. So now we can shift from IAC to the work that we deploy in Numena, in my company. So in my company, we implement data-informed solution for spatial analytics and strategic planning, which means that we use a lot of robots to decode complexity and start to encode into decision-making process digital data that can allow us to inform more our solution that can picture spatial transformations. So in this series of projects, of course, we are mixing many different experiences. The one that I personally develop in my company, the one that I also deploy with my students in the Master in Robotics and Advanced Construction in IAC, where whatever is fundamental is how to sense and how to digitize our built environment, and how to convert these digital bits into information that can really allow us to trigger new design solution. So let me just frame this presentation. We will just talk about the framework of this operation, then I can dig into the state of the art. I can give you the objectives of all the action that we are performing, and then I will show you very quickly the project that we are deploying in this world. So I'm an expert in data analytics, but personally, but whatever we do at the end has a spatial effect. So as Laura Kurgan says, I mean, there is a beautiful book that I invite you to read that is called Close Up at a Distance. And Laura Kurgan in this book speaks about the big shift that happened in the moment that the Bill Clinton administration opened the access to data, GPS data, to the world population. Before, this data was only used for military purposes. What happened is that a lot of applications started to rise, and we witnessed in the last 15 years a huge growth in terms of data implementation. So in fact, now today we speak about big data, but data is a full word. Data can be considered, let's say, in two different segments: structured data and unstructured data. And the unstructured data is all the data that is connected to this media. It's complex to catalog in an Excel file, okay? In a normal format that allow us to say, okay, that can be described numerically. Medias are complex to be described numerically, and that's why media are complex to be used in terms of information. Or let's say media were complex to use by computers. What happened is that thanks to machine learning and neural network, it is nowadays possible to create a new connection between images that are unstructured data and spatial phenomena. So all the stuff that I do in my company with my colleagues, and I also research personally with my students in IAC, is how to connect image-based data to spatial phenomena. They can serve for establishing new design protocol, or they can serve to trigger different fabrication processes. So the state of the art of those media rely on the evolution of computer vision and machine learning, but mostly the action that we perform are connected to one specific approach that is called object detection. So how can we recognize object in an image? And we can do it in real time or implementing deeper algorithms that works at maybe 13, 15 frames per second. So they are a little bit slower than a real-time process. But what is the challenge behind it? The challenge is how to use this data set that are quite complex to sort and classify media, images, in a way to encode or spatial analytics, maybe also define fabrication process. So this is the challenge of this approach. But this approach is deployed at the end through the master and my professional experience at 3 different scales: the urban scale, the building scale, and the environmental scale. At the urban scale, you will see, I will go deeper later on this project, but let me first clarify that all the approaches that as a company we deploy are always responding to a very similar protocol. So one that is crucial is connected to data collection. So how to automate a system that can capture information from our environment. Other approaches are connected to digitization. So after data is collected, how can we represent this physical environment digitally? And doing this representation means that we start to build digital twin where information suddenly becomes a new material that we can classify, that we can sort, that we can reorganize. And in this environment, this information suddenly becomes a new triggering source that allows us to look deeper at spatial dynamics and start to implement machine learning and artificial intelligence to explore these spatial phenomena, often associating static and dynamic components into one unique scene. All this knowledge at the end is very useful, not only to represent whatever is in front of our eyes, the present, but also to start picturing future behaviors, future performance, where suddenly all this new data set that we can encode can become a system that can be used also for predictive modeling. So let me use some cases from the urban mapping, the urban scale. We are working with Barcelona Regional. So look at how we operate. No? I spoke about the university. I'm now speaking about my company. But there is always a huge interconnection between these systems. So at the urban scale, we work with the Department of Urban Development of Barcelona. You know that in 1992, there were the Olympics and Barcelona changed her face. And this is thanks to this department that works at the urban scale, but also it's a department that wants to explore new instruments. So what we did for them, what we are now doing is include and create new platform, new instruments that allow us to analyze spaces, including system for object detection that can give us a more real-time picture of which are the actors that are occupying a public scene, how much they are polluting, how can include this system into, at the end, a data set that is optimized to store information and support urban planners in the activation of new dynamic system and protocols that can shape a different cities. No? So how can we block the access of cars if suddenly there are too many? How can we envelop the urban environment and create plazas where before, 1 minute before, 10 minutes before, there were cars? All these systems are responsive systems that need to respond to real-time challenges. And for this, we use computer vision and machine learning. And on the other side, we also include automated systems that want to improve the resilience of our cities, promoting the urban transformation, including urban greenery, so including trees, plants, etc., to lower down the heat levels of our built environment. And this is possible by analyzing the shadows, for instance, that is produced by the trees, the CO2 that is absorbed. And in order to do this, we use robots to collect data and analyze plants and their robustness. And in the same time, overlap thermal data that allow us to measure the heat levels in those given environment. Why we do it? We do it in order to create metrics, spatial metrics that can support urban planners in the distribution of greenery in a practice that is at the urban scale called as urban forestry. Now, talking at the building scale, in the company and also in the IAC, we are again using point cloud in order to classify the different components that are part of a built environment. And we do that by creating clusters and segmentations that allow us to understand the nature of every single component in space and start to shift towards building information modeling. But that's not the only thing that we do. With my students in the Master in Robotics and Advanced Construction, we also use image analytics to start classifying the different materials that are part of a building site where the building needs to be demolished. And before demolition, we use data collection, automated system for data collection, to start classifying the materials that are part of the scene, starting to associate each material to a specific family of elements. And this is also a process that I would like to show you. Is a startup that we launched with the Master in Robotics and Advanced Construction and is now incubated in Paris, in the Riven program. And with this startup, as you can see, starting from the point cloud, the photogrammetry, etc., we started to analyze all the different components that are part of the scene, starting to represent this new complexity into an interface that can be used to bring back in the construction cycle materials that otherwise will become waste. Okay, so this is also a very important approach, another justification, another demonstration of how can we use sensing machines in order to trigger spatial transformation. And on the other side, let me conclude with the agricultural scale, in which, again, is agriculture, but agriculture means is also a space and environment that we need to design. No? It's a space and environment that we need to program. And in that sense, it's 5 years that we are working with Sony, Computer Science Lab, IAC, Humboldt University, CNRS, INRIA, and my company of Lumena, in order to deploy automated system that can allow us to observe the environment and on the other side cooperate with farmers supporting agricultural practice. So from one side there is the eye, and on the other side there is the hand. And what we built is a new platform that is called the Farmer Dashboard, that allow the farmers to extrapolate information from its crops and implement system of machine learning and computer vision that can allow us to track the growth in time of a given plant, providing curve levels of growth and classifying every single plant according to a protocol of machine learning and computer vision. So this catalog is then connected to the digital platform that tells you in time the growth of this lettuce, if this plant is getting enough water, it's dry, it needs to be extracted from the soil, it's measured or not. And at the end, this all built in order to facilitate the farmer in the creation or generation of instruments that can improve the efficiency of those environments. Then let me conclude with the last project that is again connected to the agricultural and environmental scale. This is a project in which we've been using data collection and automation in order to rethink our material resources from the beginning, so from the forest. We've been using automated system of 3D scanning to create discrete catalogs that could improve the efficiency of laminated wood panels and facilitate the generation of bended elements that could immediately be allocated in a specific place in the forest. So all these parts support a custom lamination that wants to respond to specific project requirements where there might be more complex or articulated geometrical shapes, but at the end we go back from this from the full cycle of sensing and manipulating matter. And in fact, as you can see, all this sensing device is afterwards converted into a manufacturing protocol where the sensing panels are manipulated and converted. And to conclude, I mean, these are some of the publications that we've been producing, but I want to speak a little bit about the future, which is the future of construction. And the future of construction is a future where all these capabilities of sensing, all the capabilities of novel tools of manipulation, design protocols, etc., will come together. For us, they will come together in a cooperative way. These are design drawings from Thomas Bock from the late 70s. But in a distributed manner, no? Where every single sensor will be connected to the other, generating at the end a network of solution where the linearity of the process will disappear. So no more design to manufacturing, but actually a new loop will emerge, a new loop where sensing data will reconfigure design protocol and will establish novel manufacturing process that can still cooperate with humans. And how to do that? I mean, this is some of the things that we are exploring in the mass and robotics and advanced construction, but I will rather say these are things that all together, also with your university, we are exploring nowadays. And this is evidently a direction where we can all contribute in terms of innovation and growth. Thank you.
Thank you, Aldo. That was really a very interesting presentation, because a lot of these things that you discussed, we have heard in theory, but to see see you explain your projects. I think it gives a lot of the students, especially who are present in the attendees list. I mean, I'm sure they would have learned quite a bit. Personally, I had one question. So usually in heritage, so I'm a heritage conservation architect. So we work with the restoration of buildings. So a lot of the times we would document like physically with like measuring tapes and really rudimentary tools. We would document like buildings, and then based on whatever the requirements are, we would have to reconstruct an entire building. So how do you see robotics and everything that you have discussed? How do you think this could help a field which really requires a lot of detailed documentation and then kind of replicating the same thing, but maybe with slightly better materials? So do you think this field could help out heritage conservation?
Thanks, Shreya, for your question. That is very, very good question and absolutely on the spot on what I was mentioning. So thanks a lot for it. I mean, this is crucial in you know, recovering our built environment and understand how these technologies can enhance systems that can still provide a new life, not to these habitats, to these materials, is crucial. Again, everything starts from my perspective on our ability to sense and digitize this information, starting to catalog and classify the operation that afterwards are necessary to provide better stability, gain back structural capabilities, and maybe enhance new material performance. This is absolutely critical, but it always starts from this cohesion between the digital and the physical world. So the physical world at the end becomes the triggering input that we can embed digitally in our design protocols and establish together actions. If you want, again, Shreya, nowadays we are working exactly on this. If you want, you can also visit some of our pages from, for instance, from Lumena, where we have images. Maybe I can share it uninformally. I mean, it's I think this is more a conversation that is more uninformal. But you can see in this case, we are using computer vision to detect cracks on a wall. And in fact, those cracks are afterwards classifying even the essence and the nature of the wall and defining, and this is the original input. So this is just, for instance, one aspect. And on the other aspect, the classification of those components that might be damaged or not. And evidently, this leads toward execution criteria, where immediately all these actions can establish a logic of intervention.
Yes, that is really interesting, because what we usually do is we measure it and then we have like so many papers. But I think here the analysis part becomes much more accurate when we use tools like the ones that you just mentioned and you kind of showed us. Another question that I would have is, if you look at like the pedagogy of how architecture is taught, these are looked at technologies which are still very far away. So we are still teaching architecture the way we learned it when we were in architecture college. So how would you probably, you know, I mean, to all the faculty members listening, what do you think would be the right direction for the field of teaching? I mean, how do we inspire our students to start looking at these emerging technologies, if there is something that, because you guys have already done it. So if you could probably give us some.
No. That is also another excellent question, Shreya. Thanks a lot. First of all, I mean, this doesn't represent a point of divergence. This is a new chapter. So the very knowledgeable professors that are teaching in your university don't have to be worried or scared at all. I mean, their knowledge is the essence of this new knowledge. So whatever you see in a presentation like this that is pointing out the technological impact, the impact of those technologies and the implication of those technologies, it wouldn't exist without a solid base. So what I promote is actually more the possibility to use the academia as a common ground where to experiment and understand the find out those convergences, start to create new knowledge that really can have the maturity of a culture that we've been as architects, researchers, etc., building for a generation, for centuries. So this is just a new chapter. And someone said that we are just small men on the shoulders of giants. So these faculties and this knowledge is the giant, and it's the giant that we need to work with. Okay, that said, maybe I will promote a new collaborative approach, where faculties that are coming from such environments like IAC, ETH, ICD, Michigan University, etc., all this ecosystem can be represented also in the educational path of your school. I think this is an important bridge that you need to establish, but you're already doing it, inviting external professors.
Yeah, that's true. That is true. Yes. Thank you so much, Aldo. We have a question by Shivalinge Gowda. If he could unmute himself and ask the question. Also, the question is visible in the Q&A panel, Aldo, while we try to reach out to the participant.
I will see.
Yeah, he asks, what are the materials which you are coming up with for the future urban construction scenario, like high rise and everything? 3D printing with reinforcement is a challenge as of now. Is there any alternative research from your end? Please throw some light on the same. This is the question.
Okay, how can I pronounce his name?
Shivalinge.
Shivalinge, okay, Shivalinge. Okay, first of all, we have a lot of students from India in our university, and a very good one is in Mumbai, and he was working, and I say hi, Shashe, and he was working on concrete reinforcement. So actually it fits very well, Shivalinge question. And materials are the key. Honestly, today I wanted to speak a little bit more transversally on the design protocols and the experimentation that we do in IAC. But material is the key also of the action that we are undertaking in my company. And materials are the key also for their ecological impact. So concrete, for instance, that you were mentioning, is one of the most polluted materials in the world. I'm not against concrete, but we need to understand how to start manipulating in a different way this product. We are moving up and down in front of me, 3D printed pieces from my... No, don't worry, don't worry. And I want to just underline the fact that even if you read the book of Bill Gates, How to Avoid the Climate Disaster, you will see how clearly another person that is not an architect, that is not a builder, is a technologist, describe the impact of concrete. I mean, very, very clearly. And that is a way that I also challenge our faculties from IAC and your faculties to reach as a clarity. We need to be aware that every single choice that we do from the design process to the materialization of it has an impact. So rethinking material is a super important challenge, and reconsidering how we can implement process of automation that can underlie a new intelligence, a new material performance is super important. So with Shage, we were exploring an advanced system of concrete reinforcement that could respond to structural performance, local intelligence. And I invite you also to have a look at it.
Thank you, Aldo. I hope that did answer the question. We have another question by Professor Rakesh. If he could unmute himself and ask you that question.
Sure, if you want, you can also read it.
Yeah, I'll just read it out. What's the ratio of humans and robots in construction? I mean, this is like a very general question.
I don't know which is the ratio, but what I do know, still we are more, I could say. But what I can tell you is that there are very few robots on a construction site, and this is where we need them the most. I've been speaking with OVARUP. I don't know if you know, this is a very important agency of construction that has been working with Ramkulas for many, many years. And if you speak with them, you will also understand where we are less efficient. And the construction site, for instance, is a big black hole where suddenly all the beautiful ideas that we have as an architect with the BIM, with the computational design, with this controlled and clean process of design to manufacturing suddenly disappear, and chaos reign. So it's a very uncontrolled environment where implementing systems that can allow us how to improve it, how to make them more, make them safer, more efficient, can be, it is the challenge. And it's an environment where maybe we are speaking about robot, but I would rather speak also about data, you know? And consider that for OVARUP, we are losing a lot of, I mean, in general, a project can represent in terms of cost, 1/3 of is lost because of the construction site and because of the inability that we have to monitor and predict the real time of execution of our projects. So I would rather start to think instead of where are we and where are the robots, in how can we start to be implementing a more efficient construction, you know?
Yeah, because time is again a resource, and if our efficiency and if, like you mentioned, even the safety increases, I mean, that's a very, especially in third world countries where we have mass constructions and a lot of labor involved. I think these kind of measures can really go a long way into ensuring that even the sustainability of the site and the quality of the people working on the site really increases. So yeah, this is a really great step ahead. But yeah, I mean, Aldo, thank you so much for joining us. We've had a wonderful time and we've all been looking forward to this session. And you did apologize that you were late, but in all honesty, we've all been looking forward to the session. So thank you so much for your time. Thank you for giving us this time.
Just from my side, yeah. Hi, Aldo. I'm Dr. Shaila, Director, BMS School of Architecture. First of all, a very nice presentation. Thank you so much for, being a part of this wonderful session. And to be, we already signed an MOU with your school. I think this is the best opportunity to us to explore more, because the content is really, really good. I'm sure this is going to be very helpful for our students. I think now onwards, I think we need to explore more about our collaborations. I think it's just 1 year back we signed a MOU with your school. So I'm sure this coming, maybe in coming 1 or 2 months, we will really explore more and then we'll come back to you again. So thank you so much, Aldo.
Thanks to you, and you are more than welcome to collaborate with us. I mean, I guess it's our responsibility to inspire, the new professionals of the future that are our students, and the best way to do it for sure is to collaborate and sharing knowledge. So you are more than welcome to get in touch with us. Let me thank you, Shaila, and Dr. Shaila, and Shreya, and all the school for this opportunity. Dr. Shashank as well, Professor Shashank as well. It was a pleasure from my side to be part of this lecture.
Thank you.
Thank you so much, Aldo.